We will continue with part 2 now. Yesterday we have seen how to set up HA proxy or load balancer on CentOS 7.9 machine. I have gave you the detailed steps. What are the different steps? How to install the package, how to modify the config file of HA proxy, and how to start the service. And once your service is started, how to confirm whether your HA proxy is actually running or not. I will continue my second part from there only. So yesterday we have done this configuration. I have checked my HA proxy is running absolutely fine. And if I go further and if I type netstat minus tlnp, you will come to know that my TCP socket is open on this IP address with port number 6443 on which your API server is running. Correct? So my first part of this multi-master setup has been done successfully. Correct. Now the second part which we have discussed already, that we would like to set up the Kubernetes cluster right now. Okay. So I have 2 master and 3 worker which is already created or already provisioned on the top of our virtualization. Now we are going to start creating and providing all the step-by-step procedure in order to set up the multi-master environment. Now before we go here, there are few checks or you can say prerequisite you are supposed to do it. Now the first check should be done on your every machine. Okay, that is SE Linux setting should be, or you can say SE Linux configuration should be permissive. Okay, this is currently mandatory for every Kubernetes setup because still there is a development going on how to make SE Linux compatible for Kubernetes cluster, but currently it is recommended that SE Linux should be permissive, so no kernel blockage should be happening. Okay, now for our training purpose or learning purpose, I disabled it. Okay, so for this video or you can say for this particular demo, I have disabled it. But normally if you are working on a production side, you will see that SE Linux is permissive. That is the first. Second thing, firewall should be configured according to the necessary settings for Kubernetes. Now in my case, I disabled the firewall, but you are not supposed to do it in a production environment. Whatever necessary ports, logical port numbers are there, I will show you in the documentation as well while we are proceeding this. There are some logical port number you are supposed to turn on, or you can say allow that particular traffic to be passed through this particular firewall. Now in our case right now for this demo I have disabled it, but in reality in production environment you will not see or you will not be able to disable the firewall in your production environment. Firewall is always turned on, and whatever necessary port numbers or logical port numbers should be open there. Okay, this is the first. Then swipe space should be disabled. Now currently this is not necessary for Kubernetes version 1.28 onwards, I believe. You don't require it. Currently your kubelet is ready to work with the swipe space. Okay, so means if you do not disable it also, it's okay. It is not necessary nowadays, but if you look into the previous version of Kubernetes, it's clearly instructed that your swipe space should be disabled. What is the meaning of it? Clear cut meaning, your whatever memory consumption which Kubernetes would be doing, it should be happening into main memory. Kubelet should not consume any of the swipe space in the case of memory outage. Correct? But currently it is not necessary. However, I am following the same strategy because I have been working with the Kubernetes from past version. I feel that disabling the swipe state does not create any huge impact in a production environment, because in production we have a huge amount of RAM or memory. Even in our demo, we are not running too much traffic or too much workload to be created. So if I disable the swipe sets, doesn't matter. But it is necessary in previous version of the Kubernetes. Right now, if you do not disable it also, that's okay. Your kubelet or Kubernetes cluster will not create any. Course number, networking should be properly configured, as well as name, machine name should be set up properly. Okay, machine name means the host machine which we are going to set up, that has to be configured properly over here. Correct? Because that is the key factor when you are initializing your cluster. Cluster internally identify all the connectivity by your name, and he will register your name to the cluster information. That's why it is very important that whenever you are setting up any cluster, proper name, unique name, that is necessarily I have to mention it, unique name, unique MAC address, unique universal identification number has to be there. Correct? So that is something which is very important, because internally this information would be consumed by your cluster. Correct? And name resolution should be properly configured. Means what? Simple meaning, your etc/host file should be properly configured. Okay, we don't have a DNS server in our environment. Okay, so better example or better option would be this one. So this is a necessary setting. You are supposed to check on every worker as well as your master. So that means this setting which we are discussing right now at this moment of time, this all setting has to be configured on all the machines. Okay, so all the machines, or you can say nodes which are involved in order to set up your cluster, this is a common setting which we are supposed to do it. Correct? Now this is already prepared machines which we have it, but I will show you how to do it on one of the machine. Okay, you have to repeat the same identical procedure to every machine. Correct? So if I go to my machine over here right now, I do have a master available at this moment of time. So I have taken the putty session for my master machine. So first of all, you can see the name is properly set up. So if I say host name command over here, so this is my proper host name. Now if I would like to set up any host name, okay, so there is a command called as host name ctl set hyphen host name. Then whatever name you would like to provide it over here, for example, I would say Mangesh123. This is the name of the machine you are supposed to configure it. This is just for an example I am giving you. You can press enter, your name of the machine would be configured over there. Correct? So for the time being, I will go ahead and execute this. So you can see the machine name has been changed. Okay, once again I will go back to my original name, that is called as master hyphen. Okay, the This is the command you are supposed to use it in order to create or in order to set up your name. Correct? Okay. Second thing, I told you that your SE Linux is disabled over here. So if I execute get enforce command over here, you would see it disabled. Okay. Normally you will get three options over here, enforcing and permissive. Okay. And the third option is disabled, but disabled cannot be done with the help of command line. If I would like to disable the SE Linux feature, I have to modify some file. Okay, which file? So if I go here, etc SE Linux config, you would be able to see this is a SE Linux configuration file, and here SE Linux is equal to disable is the value which I would like to set up. But there are three values are there: enforcing, which is a default one, permissive is the second one, and disabled is the third one. But first two can be done with the help of command line. Okay, disable cannot be configured or disable option cannot be set up on SE Linux with the help of command line. You have to open this file, do the modification into this file, and you have to reboot the machine. Okay, in order to get the effect of this disabled, you are supposed to reboot the machine. Now this I am telling you because I am doing demo. In reality, I told you disable is not the right option. Permissive is the right option which you can use it over there. Correct? So my SE Linux has been successfully set up. I told you that systemctl status firewall D. Now technically I disabled the firewall from all the machines. Okay. So this is also not compulsory. Normally in our production environment, turning off the firewall, it's a risky part. So it is always recommended that if you are dealing or if you are implementing production level environment, your firewall should be turned on. Whatever necessary logical port numbers, okay, that needs to be allowed on the firewall. Okay, sometimes firewall and SE Linux, two major culprits are there from OS side to create the problems. However, if you set up these two parameters properly, nothing will hamper or nothing will create a problem inside your cluster. Your cluster will run very smoothly. So I have gave you how to set up the name. I have tell you that how to get the information about SE Linux, and I am telling you that if I would like to shut down the firewall, simple commands are there. Systemctl stop firewall D. I stop it. It's already not loaded. It's giving you failed to stop, but I executed stop command, then I executed the command called as disable. I disable the firewall, and accidentally nobody can enable it. For that reason I have masked that service. Okay, so I mask that particular service also, so accidentally that somebody should not enable that service accidentally. Correct? So these three things are very important. After that, I told you my swipe space should be disabled. So if I execute a command called as free, you would be able to see my swipe space is going to show you 000. If your swipe is not disabled, you are able to see some values according to your configuration over there. Whatever values are selected for swipe space, that much memory or that much space amount would be displayed over there. But currently it's saying 0 because I disabled it. Now this is also can be done on the fly. That means with the help of command line also I can turn off the swipe space. There is a simple command called as swipe off -a command is available. But this particular command would be running for that particular session. If I reboot the machine, once again your swipe should be turned. Correct? Now to avoid this kind of conflict, what I did, I will go to the main file called as etc/fs tab, and I will go to the line number 3 where the swipe configuration line is available. I commented this particular line. I put a comment on this particular line. Because of this comment, whenever your machine is booting up, your swipe space will not be loaded. So this is a permanent solution. Okay. But if you would like to go ahead and if you would like to run it as a runtime solution, swipe off command is also available. Swipe off -a, this command will also work, and that will help you to shut down your swipe with the help of command. But once again, if I reboot the machine, once again swipe will come up. That's the reason I modify this particular file and I actually comment the line number 3, which actually help your machine to load your swipe option or swipe memory space on your machine. We comment that line. Once again, if I do the changes, and the effect will happen after reboot the machine. So remember that is also necessary. Once again, these all settings would be done across all the 4-5 machines whatever we have implemented. Similar steps. Okay. After that, I told you that your name resolution should be properly done. So if I execute ping command master-1, you would be able to see I am able to resolve the name with the IP address over here. Now it is pinging himself right now. Now I will try to ping master2. You can see the name resolution would be actually working. Worker1, you can see worker1 is also resolving their name. If I go to the worker2, subsequently if I go to the worker3 also, you can see the name resolution is working absolutely fine. That means the etc/host file, there is a file called as vi etc/host file, which actually help me to resolve the name. If I don't have DNS server in my environment, it will resolve the name locally. If I enter it, this is the entries which we have made. Okay, so you can see here I am including load balancer also. Now technically don't require load balancer because this is a master. I really necessary to have this 5 entry. Okay, you can see this is the entry of himself, its own machine. This is the entry of master2. This is the entry of worker1, worker2 and worker3. That means whatever nodes or whatever workers which we have involved, I do have the entry of this all machines over. Now technically if you have a huge cluster in your environment, this is not the reliable thing. That's the reason we should have a DNS server available inside your environment to resolve your name. Correct? But currently we don't have that setup available. That's why we are going to resolve our name by its local etc/host file, and this is just a demo. In production level cluster, this is not the scenario. Correct? So you can see this is the IP address of the master2. This is the FQDN, that is a fully qualified domain name, and this is the name of the machine which we have. Correct? Now these entries are populated inside this file, and I have saved the file. Same equivalent settings you are supposed to do it on the rest of the machine. That means whatever I have mentioned it over here, SLNX permissive or disable it for our demo purpose. Firewall should be disabled for our demo purpose. Swipe space should be disabled. Networking should be properly. Machine name should be properly set up. Name resolution should be configured. etc host. You have to perform all these settings to all the machine which is the part of the cluster. This is mandatory. Now you can do it with the help of script also. Completely up to you. Okay. Now in order to understand what steps are involved, that's the reason I have done the steps with the help of manual configuration. But if you feel that I can do every setting with a single script, You can write a shell script and you can execute it on every machine. That will also, but we are learning it. That's why we should know what is happening in the background. That's the reason I gave you this step by step. Correct? So my first part is done. Now let's move to the second part of it. Okay. Now the second part would be the installation of the necessary component for Kubernetes. Now what are those components? So what we can do it, we will go to the browser and we will try to access the Kubernetes documentation to understand what necessary component we need to prepare or what necessary component we need to install and configure before we create a cluster. Correct? So if I go to the Google and type Kubernetes installation, okay, just go for this particular search. The first option you will see that getting started. Okay, this is the first very basic fundamental documentation which is actually coming from kubernetes.io. So I will go to this link. Now on the left hand side you would be able to see multiple documentations are available. Now we are going for a production environment implementation. Normally people are going for learning environment in order to learn your specific Kubernetes cluster. In a learning environment, if I go there, there are very simple tools they have mentioned. For example, there is a tool called as Kind. There is a tool called as Minikube. Now they have mentioned these two tools which you can use it in order to learn the Kubernetes. Why? Because if you don't have setup or memory available, you do not have a multiple machine which you can create. So you can use these two type of setups which is technically available only for learning purpose. Only for learning purpose these setups are available for. However, we are not going for this type of setup for our demo. We are going for a production environment. Means whatever steps or whatever implementation normally happen at a production level, same equivalent steps which we are going to perform while setting up our Kubernetes cluster. So if I click onto the production environment, okay, now here very interesting documentations are provided by Kubernetes. I would request you that if you would like to work on the Kubernetes, read this documentation very carefully. Okay, so if you would like to go ahead and set up any production level cluster, these are the production level cluster considerations are available. That's what you need to consider. Correct? So these all pointers you have to read, consider while setting up your production. Correct? Now, once again, if you have a time, please read this documentation very carefully. But here, the first documentation which we are going to follow is called as container runtimes. So according to the production level environment, container runtimes are necessary to install it on your every machine. Correct? So I will go to the container runtimes. Okay. So this is a documentation provided in full detail. Right now, whatever Kubernetes version this documentation is available for, it's a Kubernetes version 1.30. Correct? Now, according to this documentation, these are the supported container runtimes are available. Correct? Now, we already discussed in our training that why Docker is directly not supported by the Kubernetes right now. What is the reason behind it? But still, Docker engine is supported by some other communities, and with the help of the Microsoft and with the help of Mirantis, they are still supporting with the Kubernetes. Correct? Now we don't want to go in detail why Docker stream is not there. If you want, I will create another video why Docker is not directly supported by the Kubernetes at this point of time. Okay. But currently, whatever container runtime which we are planning to go ahead and use it, that is called as container. Now this is open source, very stable, very reliable container runtime environment or container runtime engine is available, which is also supported by Kubernetes. I will create another video if you would like to go for Creo also. Creo also very interesting container runtime environment is available. Correct? But currently we are going to use it container. Correct? Now remember that we are going to install and configure container D on every machine. Remember that. Every machine, including all the masters, including all your workers are available. So container D installation and configuration is supposed to be performed on every machine of your cluster. Correct? Excluding load balancer. Load balancer is the out of scope because it's not directly part of the Kubernetes. Correct? So if I scroll down the page a little bit, there are few settings you are supposed to do it, and only one setting you are supposed to do it before you install containerd or any container runtime. This is necessary set. Enable IPv4 packet forwarding. Okay, this is mandatory kernel parameter which you are supposed to go ahead and set up on every machine before you go ahead and install container. Correct? So I will copy this 3 lines. Okay, and I am going to tell you one by one. Okay, so you can do it with the help of script also. Write this command into the script and do it in very quickly manner. But in learning purpose, I am going to execute this particular command one by one. Okay, so I will copy this, and right now I am on the master number 1. I am executing. I will go here. I will copy. Currently I am on the master number 1. I am executing this command on master number 1. Okay, and after that, in order to apply this parameter, I am supposed to execute this command sysctl ---- system. Means whatever kernel parameter which I have declared it over here, I need to apply that kernel parameter without rebooting the machine. So this is the command which we are supposed to execute. Okay, so you can see IPNet forward is equal to 1. This is the kernel parameter has been successfully executed. Now I have to repeat the same thing for all my machines over there. So what I will do it, this is my master 1. I will arrange it in such a manner. Now you can use tmux command also if you want, if you are very much good in tmux. Actually terminal, it's a terminal muxing command where you can add multiple terminal at the same time and parallelly execute the command. But what I will do it, I want to do it for learning purpose, so I should know what is happening behind the scene, what are the step-by-step implementation needs to be involved. So what I did, I am doing it explicitly manually over here. Okay, that is something we can do it. Okay, so this first set of command which we are supposed to execute it on every machine first. So I will go to the master number 1, then I will go to the worker number 1, worker number 2, and worker number 3. Similar command I executed on all the 3 machines. Now I would like to apply this setting, so I will go ahead and simply go ahead and copy paste it on every machine. So I have already done it on master 1. I have to do it on master 2. I have to do it on worker number 1, worker number 2, and worker number 3 respectively. Same command. Correct? So my first step is done over here. Correct? Then you can go back a little bit over here and click on to this container D. Now directly you will go back to the containerd section. So whatever prerequisite is available for installation of containerd, we have done it. Now here, the first thing is we are supposed to install containerd on your machine. So here there is a documentation is available to install containerd on your system. Follow the instruction on getting started with containerd over here. Correct? So you can simply right click on this and open it into the new tab. So you will get a GitHub page over here. So you would be able to see installing containerd from official binaries are also available. If you feel that entire installation has to be done from the basic binaries, that is also available. However, this is quite interesting method which people are using in a production environment. Okay. However, we are doing for a learning purpose, so there is a shortcut. What is shortcut? If you scroll down a little bit, there is an option number 2 is there. That containerd can be installed in the form of package also. Correct? But who is distributed that package? Docker. That means you have two choices. Either you can go to the official binary links, download necessary binary. Step-by-step instructions are given on the first option over there. You can please follow that option over there, and you can simply create and install and configure your containerd. Okay. Then the second option would be that you can install containerd with the help of yum repository or apt install repository over there. Okay. Then the distribution of that package would be done by Docker. Okay. So if I want to execute any of the installation like this, you are supposed to follow the Docker documentation for it. Everybody know that Docker internally use what? Containerd. We have seen in our containerized training actually how Docker is consuming containerd to actually run the container. Correct? So if I go to the CentOS over here, okay, you can see you are redirecting your page to your Docker engine. So better way what I can do it, I will try to open the new tab for that particular installation page. So I will click on it and I will follow the Docker engine documentation to install containerd. I am not installing Docker over here. I am taking the advantage of Docker engine repository to install containerd as a RPM package. Correct? So if you go a little bit down over here, the first line will help you to install yum utilities on your every machine. Second line is a command to add the Docker repository inside your machine from where you can download and install containerd. So what I need to do it, I need to copy the first command over here. Okay, I will minimize this page. I am doing it in master 1, master 2, worker 1, worker 2 and worker 3 parallel. Okay. So this is, I'm just installing yum utility on my machine. Okay. So you can see I am doing it on every single machine over here. So worker 1, worker 2 plus whatever master which we have it. We are installing everything on every single node over here. So you can see it's actually the part of the same virtualization. So sometimes it will take time, but if you are going for production level environment, we are not doing it like this. We have a script already prepared. We will run that script. He will do every prerequisite for your production level cluster. But If I got that particular script, I can run it and I can create my machine within 2 minutes, but you will not able to understand what is actually happened, what command is executed, why it is executed. That you need to understand. Okay. Once again, I will go back to the documentation. I will go for my second line of the command, which is actually adding the repository to your machine. So I will execute this command into master1, master2, worker1, worker2, and worker3. So this command will not do anything. If I execute yum repo list, it is going to add only the Docker repository over here. Why we are adding this Docker repository? Because I want to install containerd. Okay, I don't want to install Docker. I just want to install what? Containerd out of it. Correct? So if I go ahead into the next step, you will be able to see the yum command over here to install all the softwares over here which is necessary for Docker. But out of that, which one is important for this? This is the only package which is important for me. So if I go ahead and execute the command like this, yum install containerd.io -1. So this is the only package I want to take it from that repository and I want to install it on your every machine. So I will take that package. I will do the same command to master2. I will do the same command to worker1. I will do the same command to worker2. I will do the same command to worker3. So I am taking the advantage of the Docker repository to install containerd on my machine. Correct? It will take hardly couple of seconds in order to finish that installation. So that is my step. So I don't require this repository documentation any further. I will go back to my installation of the containerd documentation once again. So let me check whether the installation is happening. Yes. So it's happening parallelly everywhere on master1, master2, worker1, worker2, and worker3. It is done. Okay. Almost done it on worker3 also. Correct? Now, once this step is done, once again, I will go back to the documentation. Now, whenever you install the container D on your machine, we need to generate the configuration file of your container. Okay. Why it is necessary? Because if you look into the documentation over here, now we have to configure systemd cgroup driver for your container. So there is a plugin or there is a parameter called as systemd cgroup. I have to change that parameter from false to true. Now this parameter is only available in a configuration file. Right now, whenever you install the containerd on your machine, that installation will generate any configuration file at this moment of time. You can go ahead and check. If I go to vi/etc containerd, there is a file called as config.toml. Now, whenever you install this particular containerd, the demo file has been created. Okay, but this file does not have all the parameters which we necessarily require. The demo file called as config.toml will get created when you install the package, but whatever parameters on which your containerd should be working, that is not there because that is a default file. So in order to generate that file, we have to create the config.toml once again with the help of some advanced containerd command. So the same documentation which we are following, if you scroll down a little bit, there is a section called as advanced topic, and you can see containerd uses the configuration file, this one, which we have seen. Okay. Now the sample configuration file is found there. That means whatever configuration file which we have seen, that is a sample. But the default configuration file can be generated via this command. So actually I don't want sample. I want to create default configuration of my container. And that can be generated by this command. Remember that this dot is a full stop. It is not the part of the command. Okay, otherwise if you take this particular dot, your command will get an error. So be careful when you are doing copy pasting. So this is the entire command who can generate the config.toml. Whatever file is already there, it can be overwritten by this command. So simply right click on it and say copy and execute this particular command to every master and every worker over there. Okay. Now this will generate a different config.toml file. You can see. Now this file do have huge number of parameters. Now this is a default file. Okay. This is a default file. So according to the documentation, this default file needs to be generated because I would like to change the systemd cgroup parameters to true. Now there is a concept called as cgroup drivers. If I would like to use systemd to handle cgroup drivers or systemd to handle like a driver to manage the control groups, I am supposed to use this parameter true. Okay. Now the systemd cgroup driver, if you are using cgroup version 2, now there is lot more deeper discussion which we have already done in the case of cgroups and namespace when we are dealing with containerization. So I don't want to go and discuss about these details one more time. I would recommend you can read these documentations available over here on Kubernetes. That will give you brief idea one more time in order to understand the aspect. So my main goal to proceed further is to go ahead and make this parameter to true. Okay. Now fortunately I know on which line number this parameter is available. So what I will do it, I will go to the master number 1 first. I will open this file and I will directly go to the line number 127. Okay. This is the same parameter is there. Systemd cgroup. Okay. Right now this is actually false. I would like to make it true. Okay. I would like to make it true. I would like to save the file. And after that you can type systemctl start containerd. After that you can type systemctl enable containerd. This is mandatory. Enabling the containerd, it's mandatory. After that systemctl status containerd. Okay, so my containerd process would be started. Okay, now when I started the process, when I had done the modification into that particular file, correct. Now I need to repeat the same steps on every machine. So I will go do the same step on master number 2, go to the directly line number 127, change this parameter to true, save the file and say systemctl start containerd. Systemctl enable containerd. Systemctl status containerd. Okay, so we have done it. Now we would like to repeat the same steps. Okay, I will go to the line number 127. I will go ahead and execute and change the parameter to true and type systemctl start containerd. I would say systemctl enable containerd. I would say systemctl status containerd. Okay, so I have done this on worker number 1. I would like to do and repeat the same steps to worker number 2 now. So exact identical steps I am repeating. Okay, I will open the second file. I will go to the 127. I will change the parameter to true. I would like to save systemctl start containerd enable containerd systemctl status containerd. Okay, check containerd is running fine. It should not throw any error. Okay, that is the overall idea for this. Now I am repeating the same command once again on worker number 3. Go to the line number 127. I will go ahead and change the value to true, and I would say wq. I would say systemctl start containerd. Okay, systemctl enable containerd systemctl status containerd. Okay, so whatever necessary steps are involved to create the containerd, that is done. Okay, after this we don't have any step left over here to install the containerd at this moment. Okay, so we will stop the video. In the next video we are going to see installing Kubernetes part, and then we will create the Kubernetes installation over there.